Questions are reserved for the Q&A section of this forum. So after Dr. Joyette does his presentation, everyone will be allowed to speak. You could either open your mic and speak. There are various functions. You could raise your hand or you could just unmute your mic. But during the process of the forum, please keep your mics on mute. For those of you who would like to keep your video on, you are welcome to do so. However, at the end of the forum, we're asking that everyone put on their video so we could get a photo of the group. Before I pass you on to Dr. St. Martin, while he's speaking, I am going to put up a poll that you will respond to get a baseline idea of your knowledge in terms of the use of climate data in agriculture. Dr. St. Martin, over to you.
Thank you, colleagues. It's really a pleasure to actually have you there in the second part of our forum here. To show that we are listening and we're moving forward by the feedback that you gave the last time, we wanted more time for our guest speaker, so I'm not going to take the 5 minutes. I'm actually going to take 1 minute or less. I just wanted to quickly just remind you that it is a 4-part series. We are focusing on the strengthening the climate resilience of the Caribbean here. And essentially what we want to do at the end of the 4th series, we want to actually provide the participants with some certification to allow them to matriculate in other courses or program that we have and carry through these persons in other trainings that we will have through projects, etc. Also, luckily, this is not a showman pitch, but we realize because of how ICA is, and ICA is firmly known for foot on the ground and moving forward, we wanted to use that as an opportunity to select persons for a review process, 1 or 2 persons from each country, to give them a particular award that will simulate the action. That reward is not cash in hand, people. I want to be very specific, but it could be the inputs, etc., or critical instrument or tool that is needed to get you on your way as it relates to some of the things that we presented here. There is a process where you have to submit. We were going to tell you more about that, but the process is that you have to submit a short little paragraph to your country ICA office or ICA country offices, just saying what would you do or what is the idea, why you could actually want it. And then we will have an independent committee, composed of 3 to 4 persons to actually select from the country who are the 2 persons that could actually get that jump start. It is not $1 million, people, or cash value working that, but it is really an initiative to, 1, appreciate your presence at these forums and to activate the action going forward. The baseline is that for anybody to qualify, they would have had to attend all 4 of the 4 here, and that will be your entry ticket there. So with that said, I just want to welcome everybody here. We appreciate that, and let's get straight into the matter. Thank you very much. Back to you, Nigeria.
A bit about Antonio Joyette, which he prefers to be addressed as by his first name. So Antonio Joyette hails from St. Vincent and the Grenadines, where he served as head of the Meteorological Service for over 15 years. Over the years, his research has focused on local, national, and regional vulnerabilities to weather and climate-related hazards, as well as their societal impacts. He has collaborated, been consulted on related matters, and authored several articles on these subjects, some published in peer-reviewed journals. In addition, he has shared his research in national, regional, and international fora. He is currently leading a collaborative publication that considers hydrometeorological hazards in the Eastern Caribbean. Antonio currently serves as an adjunct lecturer in climate change with the University of the West Indies in the master's program at CERMES, a certificate program with Open Campus. Antonio holds a PhD in environmental studies and an MSc in natural resources management, specializing in climate change from UWI-Caville campus. He has quite an extensive there, so I will pass on to Dr. Joyette. to start his presentation. Thank you. Are you there with us, Dr. Joyette?
Can you hear me?
Yes, I could hear you now.
Okay, seems as though my sound system, I tested it earlier, it was working. I had to change it because at the last moment, everything seemed to, just have a monkey wrench thrown in it. Anyway, since you can hear me, I would use the, can you hear me very well?
Yes, you could go
Okay.
ahead with your presentation. Thank you.
Wonderful. Okay, so just before I start, there's much for us here. I am not hoping by any stretch of the imagination that you would grasp all at the same level or the same depth, but I will do what I can anytime. And of course, there's always the presentation to which you could refer later on. So I would get right into it now and share my screen. Do I have that ability?
Yes, you do. You could go ahead and share.
Okay, let me share my screen. Share. I would like to share this screen. Okay, tell me how well you're seeing the share screen.
Dr. Antonio, we've seen your presentation mode. I don't know if that is the one you wanted to show.
No, that's not the one. Let me go again and
go to display settings and choose the other option. That will only show the presentation and not this layout.
Apologies for this, folks, as we give Dr. Joyette some time to sort out his presentation. Thank you.
Dr. Joyette, perhaps we could, even in presentation mode, once the slides are clearly visible, perhaps we could continue in that in the interest of time. Are we still here, Dr. Joyette?
Are you with us, Dr. Joyette?
Colleagues, we do apologize. Just give us a few minutes so that we could get in contact with Antonio Joyette and decide where we go from here.
Are you hearing me now?
Yes, I could hear you now. Could you go ahead and share, please? Thank you.
Okay. Okay, can you hear me now?
Yeah, we could hear and see
Yes,
you now.
and it's good now. Yes, you could go ahead. Thank you.
Wonderful. I am not certain what is the issue, so I would continue from here. So this morning we want to look at using climate or meteorological data to help farmers along to improve the yield as it goes. And as we are aware, climate is very important, and so too is agriculture, as we would see as we go along. This is basically the layout of the presentation. I'll give you a little background. We can look at some of the objectives of the presentation. We'll look at some climate elements and so on, the potential impacts on crops, and we'll look at a simple weather station that you can put together. And I did go looking, and I found some that could be purchased off the shelf at reasonable prices. And we'll look at the availability of climate data for agriculture in the region, and we'll look at accessing this information. One of the objectives would be to identify weather and climate elements that are important in agriculture. We'll also look at some of the potential impacts of weather and climate on agriculture. We'll look at some DIY components for a simple weather station that you could put together. And we'll identify available data sets and suggest ways in which they could be accessed. Agriculture in the Caribbean has remained important from historical times, if I may put it that way. Agriculture has been important from slavery and subsequent to slavery, when there were small household units getting involved in farming for food security reasons, and then we had the bigger plantations. And today, that same system has come down, or it has been inherited. We still have large plantations, perhaps not as large, but they're still large by comparison to the household sizes. And it still remains important for many reasons. It's a form of employment for persons. It's a livelihood. People earn a living from it. It's food security, especially on the national scale. It's a foreign exchange earner, which is very important. We are unable to buy goods and services without foreign exchange. And basic subsistence. Some folks get involved in agriculture just to be able to have food on the table, so to speak. Agriculture in the region right now ranges between 1 and 17%. In the case of Haiti, it's 17, and Montserrat is less than 1%. And I'll show you a graph subsequently. It's employment of persons in agriculture range between 10 and 25%. In Haiti, it increased quite a bit.
That will be understood. So you can't just say, we never looked at it for me.
This graph depicts various countries on the scale of agriculture and its contribution.
The recommendations part B, and we're going to, do our own thing or implement it our own way. But reference to those materials is mandatory in Part A.
Agriculture and GDP. So we can see Haiti on the upper left there as being a 17%, and the Cayman Islands we have here, but Montserrat is much lower than the Cayman Islands are just about the same. And we see on the x-axis there is per capita GDP, as it were. Meteorological data in the Caribbean has been used from the early 1900s, perhaps late 1800s, through the 1950s for shipping, aviation, and plantation. And it's only in the 1970s when real value was seen in meteorological and climate information after the World Meteorological Organization had done a climate change study, I think one of the initial ones, and realized that our climate was changing. Some of the sources of meteorological data, we have CIMH or the CMO, National Meteorological and Hydrological Services, we have UWI, 5Cs, and there are some other repositories around the region which source their information from some of these that I mentioned and keep it. Today we have climate and climate data being readily available through the internet. We have rapid transfer systems such as automated weather stations and satellite information. We also have to use climate models to provide information for us. We could get some historical as well as projection data. And we have regional and national archives, which we could source information from. And we have national and other specialized publication to which we could refer. Meteorology and, like I said earlier, met data and climate data are important. It helps us to understand the variations in climate that exist across countries, even from country to country, even though we live in the same large region, as it were, or some may say small region, our climate differs slightly. On a general scale, we are pretty much in the same, but there's what you call microclimates that exist. So it gives us valuable insight into weather and microclimates affecting farmers' area, lands, or the plantation. So even though you may, the Met Office may give information for a particular location in the country, it doesn't necessarily mean that other places in the country would experience the same kind of thing. And I'm certain you would say the Met Office said there was rain and you didn't get any rain. That's a good example. Weather information is also useful as an input data in crop modeling for various research applications to improve food security. And this is what it, these are some of the factors, the major ones in weather and climate. We have temperature, rainfall, wind speed, relative humidity, solar radiation, and atmospheric gases. So this is what it looks like in terms of how stuff feed in. We have rainfall and solar radiation and wind affecting, for example, evaporation, and I would give a little bit more on that. And we have atmospheric gases like carbon dioxide, which is useful in photosynthesis, and also for your overall crop yields. For temperature across the region, we're looking at the first three bars, first three lines at the top. We have maximum temperature in red, and the blue is the minimum, and then we have in the purple, that's the average. And as you can see, our temperature doesn't change much. The average is about 27, 25, 27.5 thereabout. And you can see we get up to somewhere around 32. Seldom you would see 33 and so on. That would be an extremely hot days. And sometimes we see on average maybe 20, but in some cases when they're very cold periods in the north, we would see sub-20s temperature and so on. So temperature is very important for agriculture, because as we would see later, temperature and wind would affect evaporation. Just give me one moment, please. I am looking for something I want to refer to. Right, so the importance of temperature lies in its value in the end when it's improving yield. For example, for some crops, they would need higher temperatures to maximize yield. And for other crops, they would need slightly lower temperatures to maximize yield. Other crops, it really doesn't matter. For example, the crops that we grow in the Caribbean generally has a tolerance for the temperature variations that we see on the screen here. So it's not a big issue. In previewing the questions, and I hope this will address one of the questions, one of the reasons why temperature is important is what we are seeing here. When we look on the impact on yield on the right-hand side in the final column there, we see if they have changes in temperature. If we look at the center column of temperature changes, we see just about, if we add 2 degrees Celsius change in temperature, we could see that there are double-digit changes in yield for, we have beans, rice, and maize on the first column. So for these, we would see these types of adjustments or changes or fall in yield when temperature increased by the amount shown here. So that gives us an idea of how temperature or why temperature is important as it relates to these crops, for example. This is from a study in bellies, sugarcane and citrus, and we have a 1 and a 2.5 rise in temperature, and we see that there's a change with a 12 and 20% change in precipitation. We see the results of a 12 to 70% decline in yield for sugarcane and a 3 to 5% decline in yield for citrus. So this brings out how important temperature is. For rainfall, this gives us a general idea of what rainfall looks like across the largely the insular Caribbean. It may look slightly different for Guyana and Suriname. This is the bar graph here gives you an idea of how the rainfall changes over the months. As you can see, in our dry season would be somewhere between January to April, and thereafter we would have the transition month of May into the wet season, and we tend to have a slight bump around the May, June, and then another bump around September, October days. So we have a bimodal rainfall trend, as it were. And this is what it looks like away from all the clutter of the other things. So this tells us that in the first couple of months of the year, we would pretty much be plants maybe just near water stress, and in the latter months of the year, the plants would probably be well off. In some cases, if it is a La Nina year, we may be experiencing a lot of rainfall, and plants may get into maybe experiencing some water logging and so on, some of the impacts that I will talk about. Right, and this gives you an idea here of the number of rainfall days across the region, and we can see it's not the same for every country. Some of the countries in the lower Eastern Caribbean have 200 odd days in a year in rainfall, and it's reflected in the rainfall totals in the northern. And I think for those of us who know our agriculture, we already know that islands from syncytials going up the road would tend to have a slightly drier climate from islands that are, south of syncytials, as it were. Now, for some of the potential impacts on crops with respect to rainfall, you would have water logging if you have too much rainfall, partial submergence if you have flooding, or complete submergence for that matter. If you have too little rainfall, you're likely to experience decrease in moisture, and this would reduce crop production. And it would also give rise to pest infestation and so on. So those are two of the larger impacts that we would experience if rainfall change either way. This graph you're looking at on your screen here gives you an indication of when you look at climate data on a very long term, as it were. I'm using here in this case SPI3, which is looking at it over 3 months on a moving average kind of scale. Then we have SPI6 on the second one and SPI12, and we can see some areas in red, and those are the areas those are the periods that were dry, and the ones in blue are the periods when it was wetter. So we see, if we look at the SPI12, we can see some long periods of wetness and some long periods of dryness. And this, again, if you use climate data and you use long-term trends, you could actually see a pattern in periods of wet, periods of dry, and that could inform you as to whether you would put more into cropping or less into cropping during that period, depending on what you cropping for, as it were. So in drought years, you may not want to invest a lot. You may want to retain some of your investment for, for dry years, you may not want to invest a lot, but for wet years, you may want to put a little more into it because you know that your yields would be greater. And we know from when you are as an avid or an ingrained farmer, once you see there's a meteorological drought, you're setting up, because the transition between meteorological drought and agricultural drought is a very thin line. It has been observed in our region that we don't even have to get to 1 on the SPI scale for impacts to be affecting agriculture. We could be sub 1, and we would be experiencing a pattern of dryness which would affect agriculture. Once it becomes very severe, you are going into hydrological drought, and then things like irrigation would become a problem. And these are some pictures that give you some indication of what happens during a drought. Your corn crop would dry up, you would have animals dehydrated, and so they would die. If you have excess water, you would have root rots, as you can see here in the bottom lower left, or you would have swamping here, in which case you see the vegetation there drowned in water, as it were. Wind speed is another category that is important. And in the Caribbean, our wind speed is relatively stable, except for when we have systems coming in. And those are the things that we need to be aware of. Over the years, from my experience, we would not receive at the meteorological services then, we would not receive a lot of calls about inquiries of wind. But when you have these outlying systems, seldom in a tropical wave, but sometimes you will have farmers calling us, for example, a microburst. If we experience tropical, some thunderstorms, the downdrafts could have wind speeds that are very high, and then you would have some microclimate where you have winds in excess of 30 miles per hour, and you would have crop damage. Wind is also important in terms of aiding evaporation. So if you have high wind speeds, and sometimes in the Atlantic you have high pressure developing, and we have high wind speeds lasting for very long times, you'll find that evaporation increases, especially during the summer months. You would find that evaporation increase, and we'll talk a little bit more about that. We see some loss of crops here due to high winds. In the case, we have banana on the top left, then we have top right, tomatoes, we have corn on the bottom left, and we have, I am not certain what that crop is. That's a tree blown down though, just to give an indication that winds can be strong enough to, even though it's not a storm, to break trees of this size that you see in there. Relative humidity, we are looking at the gray line across here. And you can see relative humidity in the, we live in the humid tropics, so our relative humidity is pretty much stable. It oscillates between a very narrow margin, except for when you're in Guyana and Suriname, you may have, well, their relative humidity would also be stable, but it would be higher than those of us, those for us in the Eastern Caribbean, at a little bit further north. Relative humidity is important in that it gives us an indication of how much moisture is in the air. The lower the relative humidity is, the more the plants would need to be cared for in terms of making sure that they have sufficient water and they're not water stressed. The higher the humidity is, the less likely your plants to suffer from water stress. Other things being equal, that is. Relative humidity is inversely related to temperature, and we see that here. When your temperatures are low, your relative humidity is high. And when your relative humidity is low, your temperatures tend to be high. This is solar radiation, and by this I am talking about bright sunshine, even though plants do use a many spectrum of the light wave band. So we live in the tropics, just about where the red line is. So this would give us an indication of during the months of May to September, we would have a little more bright sunshine in terms of hours, even though it may not be perceptible. And I think for those of us that are avid weather watchers and sunset watchers, we would see we have the extra hour or the extra hour and a half or 2 hours when the sun just peeps above, and still we have some bright sunshine. And so that is important in that the plants utilize sunshine to photosynthesize material. So light impacts on photosynthesis with salts and solvent. The plant is able to absorb from the soil and transfer those nutrients into the plant to help the plants to grow. So the shorter hours would slightly affect plants, but for us in the region, our hours tend to not to be as severely different as it were as for the northern hemisphere and southern hemisphere outside of the equator. So we tend to do very well on our plants managing. These graphs show what the bright sunshine hours were for 3 stations, Amisvale, Beckway, and Union Island. And the bottom one is Rabaca Strip, and the time periods are given at the bottom, 2005, 2006. And for the Rabaca Strip, 1989 to 1996. So this gives us an idea. And this is the same country, but you can see different numbers of bright sunshine. So we have brighter sunshine in the Rabaca is in the north, and the Beckway and the Amisvale Airport, that was the Met station at the time, have over 200 hours of bright sunshine, whereas Rabaca is over 100 and at times touching 200. And this is the same country, and it brings out the point that within country you could have microclimates. And these are some examples of damage which would reduce productivity. Once your crop is damaged, your productivity reduces, and this of course pans out in what hot in your pocket. So we see some apples here being sunburned, we see some tomatoes here, we see some banana crops, and we see some, this could be anything like pumpkin or melon or something like that. So that would be the result. Atmospheric gases are not really an element per se. There are many elements. We know that plants take in CO2 as nutrient and use it in photosynthesis. When you have high concentrations of carbon dioxide, it tends to boost photosynthesis, which spurs growth, and that's a good thing. If you are a farmer, you would like growth, and not a lot of foliage if you're growing fruit crops, but you would like growth nevertheless. And high concentrations also reduce the amount of water crop loses through transpiration. Dissolved oxygen tend to improve plant growth. For example, incorporating dissolved oxygen in hydroponics during warmer periods can improve plant growth and reduce crop time. And negative impacts have also been seen from atmospheric gases. As you could imagine, in an area where there's pollution or you have a lot of ozone, it could affect crops, and examples given here: soybean, maize, and wheat affected by ozone. In areas where there's high pollution, it would affect also your productivity. Evaporation, which is not really an element, but it's an important parameter because it considers water loss. So for us in the region, we tend to have high evaporation rate during the summer. Even though we have a lot of rainfall, we have a lot of sunshine. So it would depend, it's not high invariably. As you can see in the latter part of the year, it's the margin here changes. It depends on how much rain you get and whether or not the bright sunshine is allowed to penetrate the clouds. And you know that during the wet season, we would have a lot of cloudiness from the tropical systems that frequent the area from the African coast. So whether or not it's a tropical wave, we tend to have cumuliform clouds, which would pretty much block out strong radiation and reduce evaporation. For evaporation, this is just a reference on hot, dry days. When we have wind speeds is also a factor in your evaporation. So the higher your wind speed and the hotter and drier the day, the more you would have evaporation, as it were. If it's humid and warm perpetually, you would find the evaporation, for example, in Guyana is not as much as the evaporation for the north. To talk a bit about, I think we talked a bit about this before, so I would skip that slide and jump into what you're looking at here is DIY weather systems. So we have on the left, we have a glass jar with a graduated ruler in there, and that's done with a pen. And as long as you have an accurate measure from which to take the initial measurement, you could use waterproof marker and a jar of this kind to help you do that. We have a jar of another kind, and we see here a wind vane that gives you an indication how fast this spins would give you an idea of how the strength of the wind, and if you could work it out if you have a stopwatch and you have a reference wind speed. We have a thermometer here, and we have a wind vane here that gives you direction from wind. Sometimes it is important to know the direction from which wind comes because it may accelerate evaporation, especially if you live in a valley and the wind comes up or down the valley, you would have greater evaporation than if the wind comes perpendicular to the valley. This is a blow up of a jar. We have an 8-inch cylinder as being the larger one, and we have a smaller 2-inch PET bottle that you would drink water from. This may be a large water bottle as well, but the orifice of this has to be 8 inches. I think I have some specs later on I will look at. And then we could use this as the funnel. We need 8 inches from which the rainfall goes into the 8-inch funnel. It goes down into the bottle and is collected. And so we see graduation here on the bottle. And the bottom here, this is just for overflow and for stabilization. So you cut the jar in two and you use the bottom for stabilization and the top as a funnel. Any overflow from this bottle, so if it rains heavily, then it would overflow, and then you could measure what's in here and then use the overflow and measure, and that would give you a crude but quite reliable rain gauge if you took your time and put it together. These are some rain gauges that you could buy here in Barbados, where I am. I looked these up at a hardware store, and these are the various prices as you see here. We have digital ones on the right, and we have the ones on the left are the ones you just expose in the field by sticking them into the ground and allowing the rain to do its thing. If you notice that the orifice of the two on the left are smaller, but because these were manufactured, they are already calibrated to give you the right amounts of rainfall once it falls into the orifice for these. For wind, these are some of the, I looked these up on Amazon, and these are one of the things I've observed with electronics now is electronic items have become very affordable, and they're still for some reason very expensive for government purposes. I don't know whether it's the contractor's markup. But these are what you could purchase from Amazon. And by the way, this is a complete weather station. It has a sensor in here, and it runs from solar in this case. Yes, in both cases, they're solar driven. We have the rainfall catcher here, and we have wind speed, and here we have the thermometer, and we have the wind vane here. So it catches the important elements that you would need: wind, rainfall, and temperature. And I think those are the main ones. You could always go and find a relative humidity chart and use your temperature and wind to work out the relative humidity. So these are two examples of inexpensive stations in entirety. And as you can see, the one on the right has an app. Because it's driven by solar, you would be able to connect with it, and you wouldn't have to approach it to obtain any information from it. The temperature sensor, to expose these, and this is very important, to expose them, that is to put them in the field where they would give you, they would sense the element and give you an accurate reading. These exposure settings are standard. That is to say, when you expose it as such, you are going to be setting up an acceptable set of instrument, as it were. Once you meet these requirements, the Met Service would be well founded to collect your information, because you would have met the specifications as outlined by WMO. And the National Weather Service in the US uses WMO, World Meteorological Organization standards. So the sensor must be mounted at least 5 feet, plus or minus 1 foot. The plus or minus here is that some people may not be 5 feet and some people may be 6 feet, right? So it caters for people between 5 and 6 feet, not having to do too much bending to read thermometers, because there's an error that could develop called parallax. That is when you see the bar in the thermometer either too high or too low. The ground over which the sensor is exposed should be typical of the surroundings. So you can't have an area of flatland and then you go and put the thermometer on the mango tree. That wouldn't be typical. It would have to be representative of the entire area. It must be open clearing so that the thermometers are freely ventilated and the flow of air is unobstructed. Do not install these temperatures on steep slopes on sheltered hollow ground. So you don't want to put it anywhere that is not typical, as I said earlier. The height of any obstruction on your property, the instrument should be 4 times the height of that obstruction away from the obstruction. So if you have a mango tree that is, say, 20 feet tall, the instrument should be 80 feet away, so that the effect of the mango tree, and the mango tree would produce blockage and eddying and so on, would not affect, nor would it cast a shadow during the changing of the sun's angle on the thermometer, and so change the reading because of that. And for, if you have paved surfaces around, the instrument should be at least 100 feet away from the paved surface, and that's because the paved surface saps up a lot of heat and creates a kind of heat island effect with the immediate environment, and it goes out as far as about 100 feet. I think it's less than 100, but 100, you would be safe at 100. This is what a typical Stevenson screen looks like. It's on the left. You see the holes in the side of this housing. That's for aeration or airflow to pass through, so that the thermometer is in a representative but shaded area. You don't want to expose the thermometer to bright sunshine, because it would heat up very fast and you will probably be reading a maximum instead of your ordinary temperature. And the height of it is about 5 to 6 feet. And it gives you some specifications here if you want to build one, and that would be quite fine. And if you notice, the color is white, and white because of the reflection afforded by that color. And we see types of thermometer here. You have one that you can simply stick in the ground, and you see this one is in a case already. The glass and the shielding is already compensating for the shade afforded by the Stevenson screen. And you see here at the top of this one that sticks in the ground, it has a gap in the cap for aeration. So we have airflow in the top, goes through and comes out the bottom. Excuse me. And we have a thermometer, ordinary one. If you build a screen like this, you simply hang it in there about 1 inch or 2 from the back, and that would be fine. And then this one now, you could simply hang it at the side of the enclosure or the screen, and that would be fine as well. So that's just a couple of examples there. For rainfall, the gauge should not be located close to the obstruction, and I would probably use the same obstruction guidance. It shouldn't be close to buildings, trees, and other obstructions because of the turbulence of wind that would affect the rainfall going into the rain gauge. To avoid turbulence, do not locate the gauge in wide open spaces on elevated sites on top of buildings and so on. So you don't want the rain gauge to be in too open an area where the wind is totally unimpeded, because the wind would just simply blow the water away from the rain gauge. So you would like it in an area that's representatively sheltered, as it were. The best site for a gauge is one in which it is protected in all directions. So if you have a grove of trees, you could remove a patch that is 100 meters, 200 meters in diameter, and then you should be fine in the middle of that. The height of the projection should not, I had suggested earlier 4 times, but twice is the minimum. Anything more than that would be fine. As a general rule, the windier the gauge location, the greater the precipitation error. Just like I mentioned earlier, you're going to have rain in the gauge, but you wouldn't have the right amount of rain in the gauge. And here we have some examples of gauge. The one at the top is one that you stick a steel holder into the ground and you simply put it in there. If you notice, it's graduated already, so you just go and read off the rainfall and you are good to go. You don't have to do anything else with that. You don't have to use, all you have to do is empty the cylinder and put it back and done. It's a two-step: read, empty, put back. You want the bottom, you attach it to a post in an open field. As you can see, we see some sheltering across here, but in the idea is to expose the rain gauge in an area that's representative. We have another one here that is exposed in a field, and this time we can see the fence in the background. That is to protect the rain gauge from, perhaps animals or unauthorized persons and so on. Okay. In the region, we have all of the information to which I alluded earlier is available to some extent. Not all countries I know may have evaporation data, for example, but the rudimentary temperature, rainfall, relative humidity, and perhaps sunshine would be available from many of the national meteorological services, who are the main providers of this type of information. In the case where you consult the Institute for Meteorology and Hydrology, they would get their data from the National Meteorological and Hydrological Services. So I would say your first line of request should be the Met Services. Here we have some agromet bulletins that are provided by national services in St. Vincent, Antigua, Guyana, Jamaica, Barbados, Dominica. Trinidad has one, but I have been unable to find a contact link or a general public link on a website. Grenada has, but I have been unable to find a general access website as well. Belize has as well. So I think Guyana and Belize has been in the business for quite a while, so to Jamaica, and the other islands have gotten on board, I think, quite a few years ago, maybe 5 or so years ago, and so they would have archive data to which you could always reference if you want to go back and start your own database. These are some of the meteorological services which you can contact for information. You could either email, you could use their website, or you could telephone. The important thing is that you if you don't know what information you would need, it is best to say what you intend to do with the information. And the officers will be more than helpful in helping you to get that information that you want. You could have daily information and you archive it as you get it, or you could ask them to send you the daily at the end of the month, or you could ask them for the monthly, in which case you would have less data to deal with, and you could use those monthly to give you an annual trend. For farmers, though, I find daily information is very helpful, particularly if you ask the Met Service to give you an indication of how much rain days occur in each month. And that's very helpful in terms of planting and knowing when your rains are going to come in, so you could get the most out of the moisture and hence get the most out of your yields. Okay, I think I hit a wrong. Okay, I think that brings me to the end. The next slide was going to be references. So those are just a set of references to which you could refer, or you could ask me for anything that you didn't see referenced, as it were. Thank you very much.
Thank you for that
Thank you, Dr.
presentation, Dr. Joyette. I will go ahead, Forrest.
That we may have. We'll be taking a few questions, but before those.
Okay, I think we're having some technical difficulties on Forrest. And so now we will take a few questions. If you have any questions, you could just open up your mic and speak, or you could put your questions in the chat. Anybody has any questions they would like to ask or anything they would like to have addressed?
Okay, I saw, if you may permit me, I would start with the questions I received from you earlier.
Okay, go ahead. We'll take a few of them.
Right, there was one question that asked, how far in advance can a drought or precipitation be predicted by current technology? I think from the models, I think you could go as far out as 21 days, but you have to remember it's a prediction. And so the further out you go in predicting, for example, let me start with precipitation. The further out you go in predicting precipitation, the greater your margin of error. And the other thing you should note is precipitation is one of the most difficult parameters in climate to predict. That's because you have to parameterize clouds, and clouds is not the easiest thing to parameterize in physics. So that is one of the reasons. But you can look at models. There are models available, and I didn't give a link, but if you wish to have a link, you could go to the CIMH website. I think they have a link there too. They run some precipitation models and provide the information, but you can also go to the National Hurricane Center website, and you could use the models available there as well. For drought is one of the most unpredictable hazards there is. You might be able to look at the long-term trends in data and identify a period within which drought is likely to occur. But there is no certainty that drought will occur during that period. It depends on how extended your transition period is, drought may occur. One of the things that studies have shown, and I'm going to speak for the Eastern Caribbean, is that drought in the long term has a cycle to it. But the question is, you may see drought every, let's say, every 5 years. So you could say we have drought in the Caribbean, Eastern Caribbean every 5 years, but that's just on average. It wouldn't happen on cue every 5 years, or every other 5 years you would have a drought. So it just gives you an indication that if you haven't had a drought in a period of time, 5 years or less, then you are likely to have a drought in the following 5-year period. So you may not have it in year 6 or year 7, but you could be certain that maybe year 8 or year 9 or the 10th year, you will have a drought. So science is much better now than before. We simply encounter drought or wait for the rainfall, but now we are very good at short-term prediction for rainfall, not so good on long-term prediction. For drought, it's the same thing. We might be able to look at trends in rainfall and say, okay, this is likely to continue for the next 2 weeks, 3 weeks. But as to long-term predictions, that's a little more challenging, as it were.
Okay, thank you for that, Dr. Joyette. As with regards to time, we will go directly into the breakout groups. So what I will do now, I will be putting everybody based on their country levels, and the national technicians will assist in answering the two questions. I have placed the Google form in the chat that you will use to answer those questions. So I'll be doing the breakout groups now. Thank you.
Before you go, in the meantime, can Dr. Joy just respond to those questions in the chat? So by the time we return, they can see the questions have been answered somewhat.
Okay.
So the breakout rooms will be just for 20 minutes. You have 2 questions. You don't have to submit as soon as you're done. If you're not completed within the 20 minutes, you could complete after and then submit. Thank you. Hello.
Hey, colleagues?
Is it working now, Jenny?
I'm just trying it again, Michaela. Let me. Yes, okay, we have it running here. Thank you very much.
You're welcome.
Hi, colleagues. I have we asked for some of you all that were there before. What we try to do with that section is to really hear from you as it relates to.
Hold on, Jenny. You're actually not in a group. Hold on. Why are you not in a group?
I'm seeing 16 persons there on the screen now.
I'm in a group.
Yeah, it looks like you're in a group.
Okay. Okay, well, go ahead.
Nice. Right. So, colleagues, I just wanted to confirm that you're seeing my screen here. It is a Google form that we want to capture some of the information as it relates to the climate data. We wanted to essentially get the idea here. So if anybody could confirm just by saying yes, or perhaps a reaction, that would be appreciated. If you hear me clearly and you see in the shared screen. And we want to have this section where we're going to talk through some of the critical barriers that hinder your use of climate data, and also what actions we could undertake to address some of these barriers. So before we go into that, could we confirm that, yes, you are seeing and hearing me? Anybody from the group?
Sorry, Jenny, but you're actually not in a group. You're in the main thing. You're in the main room. So I'm going to assign everybody to the correct groups. I'll send you to Trinidad. Which group to send you to? Antigua?
So the persons that are currently here in this group, are they hearing me?
From different places.
Oh, okay, all right. Send me to Antigua then.
Okay.
I'm also not in the Guyana group. I don't know what happened.
What's the name?
Lauren.
Lauren. Okay, I'm going to send
Guyana.
you now. Yeah, sorry. You must have registered after I did the thing. Guyana, right?
I am also not in the Guyana group.
Rennie.
Yeah.
Guyana. Okay.
I supposed to be in the Grenada group.
Grenada, okay. Paul should be, is from where? St. Kitts. Elvis, are you there? David, are you there?
Yes, I'm here.
David, where are you from?
Barbados.
Okay. Oh, yes, your thing is there. I'm switching you to Barbados now. Okay, welcome back, everyone. I believe everyone should be back. Everyone was able to submit their forms or at least fill out some. Did you hear me?
I didn't get that.
I was asking if everybody got a chance to fill out their forms.
Dominica completed the process.
Not
Okay,
yet.
great.
In the
Anna
process of
didn't
doing
complete
so
that
for Barbados.
the form process.
We need that completed.
Okay, lovely. You could always complete it after and submit.
Okay, because I'm having terrible technical difficulties here at the office.
Okay, you could complete it after and then submit it. That's quite fine. So yeah, now Damien, if we could get some of the countries. I was going to
ask Damien because I was asking if he can do a closing for me because my internet is very, very unstable. By the time I speak, it cuts off, it comes back again.
Sure, no problem.
Thank you so much.
When that time is right.
Yeah, this is unacceptable. All right, cool. Thank you.
Chani.
Okay.
You know Chani, right? Oh no, you wouldn't. I'm missing.
Okay, so now if we could get one of the countries to present what they discussed, that would be great.
Hold on a minute. This Good morning.
Good morning, man. Morning.
Good morning. On behalf of Grenada, our first question that we deliberated on, barriers hindering the use of the climate data. And as a group, we came up with suggestions, information that recommended from different participants. Extension officers were not extension officers not adequately informed or lack of knowledge on the part of extension officers to access these weather information. Officers are not adequately equipped with the tools that work along with the meteorological office. Officers lack adequate information. Also, technical personnel from the meteorological department not closely linked with the officers of the Ministry of Agriculture. There should be a link a strong link between the meteorological department and the agriculture department in disseminating information on both parts. And there are farmers who are the younger ones ahead in the technology. So these farmers will be able to access this information easier and simpler. But there are farmers who are of old school or older age that may not be able to access the information or receive it that easily. So we decided that the way forward, printed materials could be disseminated to these farmers as long as it is being presented from the meteorological department. To our second question, actions taken to address these barriers, we came up with ideas like the extension officers, the farmers the meteorological people, all of us, the stakeholders, we need to build technical capacity together. We need to come to mark with technology, understand the technology, adapt to the technology, and understand so that we can share relevant information among each other. Because at the end of the day, the meteorological office, the extension officers, and disseminate information to the farmers. And there's supposed to be an easy flow of information so that the process could be completed in a timely and proper manner. Thank you.
Thank you for that. I see your hand is up, Deandra from Bahamas, if you want to go ahead.
Yes, ma'am. Good morning, everyone. My name is Deandra DeVoe, representative of the Bahamas Agriculture and Marine Science Institute, yes, in the Bahamas. So just to address the first question, what are the barriers? A few points that I did make was just overall climatic information is typically inaccessible to smallholder farmers. However, in some cases, when the information is made available, weather data that is typically collected only reflects that of rainfall and temperature. And in a lot of cases, they ignore additional factors such as like wind patterns, droughts, so on and so forth. So usually the information that's collected is just reflective upon rainfall and temperature. But of course, when it comes to incorporating that in an agronomic sense, it goes well beyond just rainfall and temperature. All right, so my last point in relation to that is just a lack of information relating to the integration of weather data into variety selection, cropping systems or patterns, and crop planning and management. So it's just overall lack of information on how to incorporate your weather data in reference to your crop planning techniques. All right, so when it comes to actions that can be taken to address these barriers, a few points that I do have listed is that the support of smallholder farmers by way of collaboration with meteorological services and ministries that are responsible for environmental health and food production, improving or updating the resources available regarding environmental sciences and its importance in spreading awareness of its importance in the agricultural industry. All right, because there's usually a disconnect between environmental health and agricultural ministries. So more of a collaboration on their behalf to just sort of increase the awareness of the importance of integrating the two. And lastly, readily available information should be communicated in languages understood by the target audience. So that's a few of the points that I do have listed as it relates to the questions at hand. So thank you all for listening to those responses.
Thank you for these responses from the Bahamas. I'm seeing Nuraj. I'm hoping I'm pronouncing that properly, from Suriname. If you could give us some of the things that you would have had differently, you can unmute your mic and go ahead. Thank you.
Hello, everybody. It's Niraj from Suriname. I'm representing Youth Agriculture Organization. Well, the two speakers before me said it already. Yes, if there is information, how can the farmers or the people who need it access it? And if you can access it, how can they interpret it in their, so they can apply it in their daily activity? And an answer to that is more awareness from the Agriculture Ministry. And in with the meteorological department to assist, even in if they want to collect the microclimate data. So it has to be, they need to work together in if this needs to be a successful project. Yeah, that's our contribution.
Okay, thank you for that, Niraj. Sharon from St. Kitts and Nevis, anything different? You could go ahead.
Yes, I just want to share one of the experiences. Excuse me, my internet is very unstable, so if I get cut off, please excuse me. I just want to share one experience that is different in that, and I think it's a good idea. What the ROC in St. Kitts and Nevis has done is that they have weather stations up, and they have a group of farmers that they would give a daily notification as to the next day's weather. It is short term, but the farmers have the option of utilizing the information and using their own traditional knowledge and knowledge of their microclimate to make decisions as for their daily farm activity. However, the long-term planning, which we spoke about for the 21-day planning, that data is normally they utilize the information coming from the disaster management from Barbados. But that is, however, is not shared with farmers, but the extension officers tend to utilize that information to be able to disseminate it to their farmers. But as in general, that is seen in the other countries, in Bahamas and Suriname, the widespread utilization of the data is not done by all farmers. And yes, promotion and awareness and techniques of how to utilize this data is also needed, and is shortfall also seen in St. Kitts and Nevis. Thank you.
Thank you for the experience and the contribution there, Sharon. I'm sure all these things will be reflected in what was submitted. I am seeing Aina from Belize. Hopefully I'm pronouncing that correctly as well. You could go ahead with anything that you would have had differently.
I also, just to contribute to the discussion here, I think in Belize we have a fairly good agrometeorological information developed by different cooperation and collaboration between partners in country, but also regionally. There is a document that is circulated at least to ministry personnel and other personnels in government with regards to the impacts and the recommendations on agriculture, the different subsectors in agriculture, on how the projections and the forecast is going to affect particular commodities. And in our discussion with the group, we realized that the dissemination of that information is not is a barrier with regards to using the climate data. More than likely, there is not a proper mechanism in which this information is shared to those who need it for actual decision making. Furthermore, interpreting that information by farmers, as mentioned by some colleagues already, is also another barrier that was highlighted by the team. More than that, just a general interpretation, it's actual using this information for particular examples, such as irrigation systems. You know, how can we use this information? How can farmers use this information for decision making with when to irrigate, when not to irrigate, and so forth. So as the other colleagues mentioned, the main actions that was highlighted is capacity building. Capacity building not only for the technical officers who are with the farmers daily, but also capacity building geared towards farmers, perhaps through a farmer field school methodology, so that farmers could be engaged in more hands-on practical knowledge on the use of climatology in their farming and their decision-making process. Also, for the use of this data to be more at a policy level, for example, in the sense that just as how you would recommend other technologies and so forth to increase production, you should also have it as something as a priority for you to make reference to the importance of agromet information, which is as crucial as any other technology for successful production systems.
Okay, thank you for that input there, Aina. We have, oh, we lost the other hand. So if nobody else has anything else they would differently, anybody else who have anything else they would like to add?
Yes, Nikhil, I just wanted to jump in here for the group on Antigua and Barbuda. I think one of the different perspective here that was shared here, in terms of the barriers, they did mention that there is an issue with pre-elasticity too. So one of the things I didn't hear from any of the other groups, but in terms of some of the weather stations being out there, there is that potential risk there. So that is something that has to be factored in there. They also made the comment that there are some useful existing, and I think Craig just put a link to it in the Zoom chat. There are some useful existing data there. The issue is one that persons probably don't know it's already there. And the other issue is the better linkage or mechanism, institutional mechanism to actually take that data and pass it on to the farmers, specifically as to what Ina spoke about in terms of the practical thing. And there's also a question there by Conrad in terms of how do we actually use that information to guide the decision-making on farm. And I'm hoping that perhaps Dr. Joyette could synthesize in that by linking the climate data or the weather data to critical on-farm decision-making, whether it relates to crop, irrigation scheduling, harvesting, application of pesticides, etc. I'm hoping that Dr. Joyette could help us to synthesize that because we are seeing it in the chat and we also got it in the group. Thank you very much.
Okay, thanks for that, Chinny. Before we have Dr. Joyette answer this, I'm seeing a hand up from Ruth. So after Ruth, we'll ask Dr. Joyette if he could respond to the question. Thank you.
Good morning, everyone. Our group is from Jamaica. Quite some of the information is similar. But we were saying that to make the information, public ed is important. And we have to be mindful of the literacy levels of especially the farmers, the various, the very literacy level. So, some persons learn by association and so on. So we could use pictures and, different jargons and so on that they're used to. So that, and also the accessibility to information and the dissemination of the information is very important. The bottom-up approach is very good. I think we need to do a lot more of that. Our minister went around the island the other day and had consultations and so on. So in moving forward to suggestions, I think, accessibility to the internet, we have the Universal Service Fund in Jamaica, where we have different points where there is internet access. So I'm thinking we need to move them inroads to probably farms and so on, so that this information is accessible and that there can be an interchange of information, and it needs to be broken down so that the layman can understand it.
Okay. Thanks for that contribution there, Ruth from Jamaica. Before we go to Dr. Joyette, I see one other hand up from Audra. So Audra, if you could go ahead and give the contribution for your country.
Hi, good morning. I will make this very short. Audra Francis Smith from Trinidad and Tobago. One of the actions that my group suggested was utilizing agricultural societies or farmers group and do the training with them, because sometimes the farmers may not reach an extension officer, but they do communicate a lot with each other. So if you have pair training, that could be one of the ways where the data, the understanding of the information and utilizing of the technology can be shared, teaching them as a group. So if they can't meet an extension officer and they call their other farmer friend, they'll get the information as well. And also sharing the general data with these groups, because they usually have meetings and general interaction on a more regular basis than any ministry would with any farmer. So those were one of the actions that we suggested.
Okay. Thank you, Audra. Dr. Antonio, if you could go ahead and take the question, that would be greatly appreciated. The question is, if more information could be provided on how do we apply the meteorological data collected to crop production decision making? So if you could give us a response to this
Can you hear me?
question. Yes, I could hear you. Go ahead.
Wonderful. I think the question is the question from the crux of our gathering here today. I think this is the real question, let's say. This is the real question that we would want to take away some semblance of an understanding for. Now, I would say this. Scientists are in possession of the answer, let me put it that way. They're the ones who have done all the long-term studies, the trends, they look at the microclimate, they could tell you what transpires on the microclimate and so on. But much of these studies are hidden away in papers and university shelves and theses and so on and so forth. Now we need to get it from there to the extension officer, who is the intermediary between the scientist and the farmer. And I think it was mentioned before that there is a gap in the knowledge of the extension officers. And I quite agree. The extension officers seem to be biased more towards the agronomics of things rather than trying to get a rounded sense of all the things that really matter, especially today with changing climate and the role that the unpredictable climate is playing in our agriculture. I think the extension, it is the onus of the extension officer. And if you could take it a little further, national governments to ensure that the extension officer is trained at this level, that he could understand the climate data that is provided by the meteorological service, and he could transfer that knowledge to on the ground to come up with a decision-making tool or a decision support tool. That is to say, we know something about rainfall, we know something about temperature. How do I make a decision with this now? He should know the microclimates and the thresholds that exist in the various ecologies. He should know the various farmers in his constituency or her constituency or jurisdiction. They need to know each farmer's level of education, because he would never be able to transfer that knowledge to the farmer. He would be trying a one-size-fits-all, and that definitely wouldn't work. Let me say this finally. When the scientist provides the data for us, we look at it and say, for example, as I was saying earlier in the breakout rooms, we would take evaporation readings and say, okay, we have evaporations reading looking a little high. So let's say evaporations are high for the last month, and it indicates that it would be high for the following month. Then we look at wind speeds, they're high, and it indicates that it's going to be high for the next couple of months. And we look at temperatures, we are in the summer. That means our evaporation, we're going to experience a lot of water loss. Now we need to say to the farmer, you need to take some precautions to cut down your water loss. Have you tried mulching? Have you tried setting up a windbreaker or something of that sort? That would reduce water loss. That's what the farmer wants to hear. But the extension officer is the one who need to take these options to him by using the decision support tool that would integrate both the farming knowledge and the weather and climate knowledge.
Yeah, Nicola, perhaps we could take Audra. I see Audra's hand is still up. I don't know if that is from the last time, but I wanted to perhaps share a brief perspective on that as well, to add to what Dr. Joyette has just shared. Thank you.
I think you could go ahead. I think she didn't drop her hands from previously.
All right. Yeah, colleagues, I think in synthesis there, I think one of the key things that we have to do, and for me that is what grounds on the farm, is to identify which of these weather things actually affect some of the key decision making here. And the key decision making in my mind would be your land preparation. How does the weather data affect your land preparation, the time of your planting, the time of fertilizing, the time of applying the pesticides, times of harvesting, etc., and also storage as well. And so if we use an example of a trigger, so for example, we're supposed to be able to have a lot of the climate data that would say, okay, if we have a rainfall, almost like how parametric insurance is done, if we have a rainfall or we're expecting a rainfall of X amount, let's say 10 millimeters a day, we are having a cascading effect where we know that these are floodings that would most likely happen in an area there. And so therefore the issue is that if a farm takes the weather information and they said, okay, this is how we are going to have the drought, or this is how my rainfall is going to be here. So therefore I now use that information to decide when I'm going to prepare my land, even how I prepare my land. We have several examples of that there. For example, in Trinidad, for the last few days, we knew that we would have at least 3 days of rain. And if the farmer has that information, then the farmer knows that if they were planning to actually sow seeds or prepare the land there in advance, that may not be the proper time to actually do that. Or perhaps they may look at a specific crop that is tolerant, like for example, what we call the dashing bush hair, to actually plant at a specific location. As it relates to the irrigation as well, the timing of irrigation, I think Ina really hit the point on that. The critical issue will be the water budget in terms of how much water is available on the farm, in terms of even, for example, influencing how large your storage unit, your pond could be. Using that climate data information and having a trend of that will give you an example. Okay, I could have, or I should dig a pond at least this size, and that will last me by the approximation of how long, and I would need to supplement or decide that perhaps during that time, because I know there's an impending drought or you have less rainfall there, and I only have X capacity of water in my pond, then that will affect the choice of crop that I'm going to grow there, or how soon I bring it to market and what production systems that I have. So that is another thing. We are well familiar with the relationship between the weather data and the time of actually applying things like pesticides and also fertilizer. So again, if the farmer has the rainfall event, and I think Dr. Joyette hinted on that, the critical aspect for me that is informing the farm decision is one, the number of wet and dry days. That is a thing that I think farmers could actually work with per month or on a weekly basis to get a sense of how many dry days we are looking at, how many wet days that we are looking at, and then use that to make decision as it relates to the water scheduling and a lot of the farm practices. So I think synthesizing it there, the critical aspect is not only the evaporation here, but looking at all of the facets there on the farm. Some of the ways that you could actually mitigate some of these things Dr. Joyette mentioned are things like the mulching, etc. But I think the key thing is to map, one, what are the weather data of interest? We said the precipitation, we said also the issue that's dry and wet days, and then map it to what are the key events, when I'm going to, how I'm going to do certain routine exercises or practices on the farm. So colleagues, I hope that at least at the end, we were able to frame and collect it that way. We would have some subsequent seminar, particularly the next one that focuses on livestock, where we are going to try to have a balance between the issue of how the weather, not only the weather, the climate, but more so how you adapt to it in terms of the measures. What are the key decisions, even as it relates to your housing and shelter, and also your feed, the quality of your forage, etc. So I hope that that information was helpful. Back to you, Nikhilya.
You could hear me, Jenny?
Yes, I'm hearing you clearly.
Okay, so I'm going to need you to assist me there. My Zoom is frozen again. So now we would need to go into the closing remarks. I had something to share, but I will get back to that. So if we could go into the closing remarks, Damian, thank you.
Okay, thank you, Nikhilya. Yes, so it's left for me now to wrap up, and to, first of all, I want to thank Dr. Joyette for a very enlightening presentation. I noted from the poll that was done that the vast majority found the information very useful and quite and very beyond that in some cases. So thank you very much for that. Of course, I would have had the benefit of you in our group. So thanks for bringing out and hammering home the whole issue of us needing to strengthen the extension services and this information at the level of the extension service so it can be passed on in a palatable and user-friendly way to our farmers. One of the things I took out, I want to thank all of those that would have made presentation on behalf of the country. I thought we had a very rich and diverse look throughout the country. So Avril, Niraj, Deandra, Sharon, Aina, Ruth, and Audra, thank you very much for your interventions. And what I think, Cheney had kind of wrapped up and synthesized what the direction that we should be going. But I want to take away, one of the biggest takeaways from this session was the whole issue of the importance of meteorological data vis-a-vis agrological data, and how we are in a new paradigm where we need to consider both of these types of data equally, so that the farmer is in fact getting the best package of information that is available to make decisions on the farm. So I want to thank everybody for joining. And if you have to travel safely. If you are logging in for Zoom, I trust you go on to whatever other tasks you have set up for the day safely. And that is all from me. So thanks very much to the presenters, to Nicalia, to Cheney, ECA colleagues for facilitating the breakout groups. And so, yeah, until the next session, I look forward to seeing you all. Take care.
Okay, so before everyone leave, apologies for that. I put the feedback poll on the screen. Also, while you are doing that, I will just share what our third part 3 of the forum will be. Everybody could see my screen, right?
Yes, Nicalia, we could see you.
Okay, yeah. Great. So part 3 will be presented by Mr. Dean Avril, who should be among us here today. And he will be presenting on the use of high quality forages to build climate resilient livestock production systems in the Caribbean region. And some of the content that he will talk about is the impact of climate change on forage systems. He will also speak upon a lot of the high quality local forage that you could use. As we all know, forage feed for livestock is pretty expensive in the islands. And there are a lot of local high quality forage that we can use to help alleviate some of these costs. So we will speak on some of these things at the next forum. So thank you very much for joining us while you complete the poll, and I wish everyone a pleasant day. Jenny, if you have anything else to add before we
just
close?
saying in the meantime, if you could just share your video, open your video so that we could get a photo, that will be appreciated. Thank you.
Yes. Can you do the photos on your end, please, Jenny? Thanks.